Okay, so today I will be solving problem 960, delete columns to make sorted 3. It was yesterday Leetcode daily problem. So let me explain my solution, and I'll explain my solution and then I'll try to program it again. I solved it with some hiccups, so this one gonna be my is my final recording because I messed up a couple of recordings. So the problem 960, delete columns to make sorted. So what's given? We have so the given is like array of strings, and every string in that array has the same length. And basically I need to return the minimum number of columns I should remove to make every string in the strings array lexigraphically sorted, so that the characters stand after each other they form a sequence, increasing sequence, like non-decreasing sequence. So how to do that? There is a brute force solution for that, and the brute force solution is gonna be the following. So let's say I have this given example B, B, C, A, and then B, B, A, Z, B, and I start. So initially I'll keep an DP array. DP array is gonna be definition DP array J. It's gonna be the number of columns I should mean number of columns I should remove to get suffix strings ending at J lexi sorted. So it's like I should know minimum number of columns I should, let's say, keep keep in suffix strings ending at J, or like not ending, starting at J, so they are lexic sorted. So DP of J is a minimum number of say maximum. It's a maximum number of columns I should keep in suffix strings starting at J, so that they all are lexi sorted. In this case, by default, not by default, but like the last one gonna be 1, because like this column has all strings that are already lexi sorted, because there is only one character in every string and a suffix. So like it's already lexi sorted. So let's check this column. So for this column, I'm gonna go every string and then compare it to the two strings, every character, and compare it to the characters from previous strings. So here we have A, so C is greater than A, and that is greater than B. So it means that this value is gonna be 1 by default. And then like I cannot use the previous column result because like it's not the string not gonna be sorted. So next one I'm gonna check like what the DP value gonna be for this column. So check if B is less than C, yes. If A is less than Z, Yes. So initially the result gonna be 1, but because I can keep the current column and keep the previous column, I need just to reuse the result from a previous one. So it's going to be 1 plus a dp of that j minus 1. It's going to be 1 plus 1, so here going to be 2. And then next next column, I'm going to define identify dp of index. So the j going to be 0, 1, 2, 3, 4. dp of 1. And dp of 1 gonna be, so this one, yeah, and previously I was checking just neighboring one. I'll need also to check the previous column here. So b is greater than a, so like I skip this check. So for this column, I'm moving column to the left. So a is less than b and b is greater than a. So no, this one will not work. So I'm comparing this column to the previous column. So a is less than z and b is less than z. So a less than c and b is less than z. That's why I'm using like 1. It was by default, but because I'm using maximum, it's gonna be 1 plus 1 here. So it's gonna be just 2. And then I'm gonna check for the 0 column what the dp value gonna be there. So first of all, it's 1 by default, maximum number of columns that I keep, and then I compare all the previous columns. Oh, actually I didn't check, like, so I checked here a b b a, so I checked a c b z b z, and a b also satisfies, but it's already 1 and then 2 here. So it's gonna be 1 plus 1 and 2. So it's gonna stay 2. So next one, I'm gonna check the 0 column and compare it to all previous columns, like AB and BA and AC, CZ, and then AB. And then I compare it. Okay, B is greater than A. Okay, so this column is null. Then I compare B and B. Okay, B and A not okay. This column is null. So then I compare this B and C. Okay, and B and that. Okay. So I'll do this. I'll do this 1 plus 1. Recorded here 2. So that one was okay, and then I compare B and A, the last one, and the first one. B and A not okay, so this one column is removed. Not removed, but not considered. And then I run out of columns. So I have dp array of this. And next I need to, so this is the maximum value, but maximum number of columns I need to keep in order to get the suffix lexicgraphically sorted. Suffixes lexigraphically sorted. And what I will do that, so because I'm checking the suffixes, so I'm assuming that, let's say, all the previous columns are removed. Yeah. So I need to derive the result, and the result is gonna be, so for this one, I'm keeping column 1, and I'm removing all to the left. And all to the left is gonna be n minus 1 minus 1. And then for this column, I'm keeping 1 to the right. It means that I'm removing 1 to the right, and to the left I'm removing 3. So it's gonna be 4 here. So 4 here. So result gonna be this array. So it was 4 here, and then for this one. So in the right part, I'm keeping 2. It means I'm removing 1, and in the left part, I removed 2. So it's gonna be 2 plus 1. So it's gonna be 2 3. And then for this one, for the right part, I'm keeping 2, so it means that I'm removing 2. And then I'm removing 1. I'm keeping 2 here. And can it be 3 here? I wonder. So it was. Oh no, it can be 3. Oh yeah, so I am for this column I am so to the right, in the right part I'm keeping 2. It means that there are 4 columns to the right, including the current one. So I'm removing 2. It means like 4 minus 2 gonna be 2. So I'm removing 2 columns here in the right part. In the left part I'm removing 1. I assume I'm removing all to the left. So it's gonna be 3 also. And then for the first one, in the right part I'm removing 2. I'm keeping 2, so I'm removing 3. So it's gonna be 3 here. And then I need to select the minimum. So the minimum here gonna be 3. And then I'll return the results 3. Return 3 as a result. Yeah, it's a little bit confusing. So the dp here was a suffix, and the number of columns I should keep, the maximum number of columns I should keep, and then I should convert it to the not as a suffix but the entire array, and assume like everything that stands left to the suffix will be also removed. So in this case, if I have this array and it says like this suffix array, and say, okay, I'm keeping 2 columns to the right, it means like I have 3 columns to the right, and I'm keeping just 2 out of them. So I mean that at least like I'm removing 1 column to the right, and then I assume that all columns to the left should also be removed. So there are like 2 columns to the left. So the result for this one gonna be 1 plus 2 and gonna be 3 here. Yeah, that's gonna be the solution. So I'm gonna go and create this. So I'll have that rows equals len strings, and then calls gonna be equal len strings 0, and then dp gonna be just 1 multiplied by calls. And then I'll go from the end. So I'll go for j in range, and then here calls -2, -1, -1, and then for j2 in range, j plus 1, and then up to calls, and then all sorted flag equals true, and then here I'm going to be for I in range rows, and then I'm going to check if strings I j is greater than strings I j2, and if it's so, I'll say all sorted is equals false, and then I'm gonna break. And in the end, if I'm gonna say if all sorted is true, then I'll say dp of j gonna be max dp of j, and then I'm gonna keep the current one plus dp of j2, and then I'm gonna have this array of maximum number of columns to keep, and I need to derive mean number of columns to remove, and this one was for the suffixes, and I need to have for the entire array. So I'm gonna have this formula for j in range calls. I'm gonna check the result. Gonna be remove all columns initially, and then I'm gonna have this result equals minimum between the result and, so in the left part I have j columns to remove, so I'm removing all columns, and on the right part I'm gonna have total number of columns to the right gonna be n minus j. And then number of columns to keep gonna be dp of so it's gonna be j plus n minus j minus dp of j. So this one is like to number of columns to the left remove, and this one there are number of columns to the right, including the current one to remove. And it's like number of total columns available to the right, including the current one, minus number of columns to keep. And then that's going to be the result, and then I'm going to return result. Let me run it and check. Okay, it's going to be number of calls. Yeah, that's it. Let's check what's here. So the same, the complexity of this algorithm gonna be of number of columns squared multiplied by number of rows. So in this case, when we have number of rows roughly 100, and then number of calls roughly 100, so the total time complexity gonna be 10 to the power of 6. Yeah, that's gonna be it.